everyone. In this video, we are going to talk about the height of instrument method, a widely used method in the field of surveying in order to determine the elevation at different ground points. So let's say this is a ground level. So we have 2 points A and B, and let's say we have to find the elevation at point B, and we are given elevation at point A as 100 meters. So we are mounting a theodolite at point A, and let's say the height from point A to the center of the theodolite is the HI. So we are putting a level stop at the point B, and through the theodolite we are determining the height H. So in order to calculate the reduced level at point B, the formula would be 100 plus HI. We would be reaching to the line of collimation, the central line, and from that we would be subtracting the H in order to get the reduced level at point B. So this is how we would be basically finding the height of the any point on any elevated or any slopy ground. So let's discuss some technical terms related to the height of instrument method. Let's say this line is the mean sea level line, and this is the ground level, and this is the benchmark. So what is the benchmark? A permanent reference point with a known elevation, like here mean sea level. So it is the benchmark, and the height from the benchmark to the mean sea level would be known as the reduced level. It is denoted by the RL. Similarly, station points are those ground points where reduced level are determined by leveling stop. Let's say here the station points are A, B, and C, and these points on these points we have to find the reduced level of the elevations. Okay, so let's say we are mounting a theodolite. Uh, so the line passing from the center of the telescope, an imaginary line passing from the center of the telescope, was be known as the line of the collimation, and the height from the mean sea level to the line of the collimation would be known as the height of the instrument, and it would be got by using formula of reduced level plus backside. So what is the backside? Let's say we are mounting a level staff at point A. So very first reading taken on the benchmark or non-reduced level to calculate the height of instrument, it is known as the backside. So let's say the benchmark reading is given. Let's say it is 100 meter, and through this telescope and staff rod, we would be getting this height H. In our previous slide, we have discussed this HI. So it means some reading, let's say this is Y. So Y plus this benchmark reading would be the height of instrument. Means height of instrument is the total height from the mean sea level to the line of the collimation. So this is the backside. The intermediate side reading taking on the point between the backside and the fore sight to find the reduced level. It is the intermediate point, means all the intermediate readings would be known as the intermediate side. So let's say this is again we are mounting the level stop at point A, and the reading on this stop would be known as the intermediate side. So the last reading from the current instrument setup before moving is known as the Fore Sight. So this is the Fore Sight. What is meant by the current instrument setup before moving means this is an instrument setup. Only three readings are taken in this setup. Means if we, for example, if we take more reading on this setup, like between the A and point B, let's say there is another point of A1 between these points. So again, between these 2 points, let's say the point is A1, and the reading on the A1 would be again the intermediate side, since all the readings between the back side and the foresight would be known as the intermediate side. Since we have only three readings on this setups, that's why only one intermediate side is found here. So why we are moving our setup to the next point? This is because let's say we have the staff right at point C, and we can't find the elevation of point C through this setup. Why? Because if you see this line of collimation, this is not intersecting with this level stop, so we can't find the height of this point from the line of collimation to the point C. So in order to get this elevation, we would be moving um, our theodolite to some other point where we can easily get the height of the um, point C. So let's say we are moving our point, our station or theodolite to this point. So again, this is okay. This point would be known as a changing point, a point where foresight is taken as and backside is taken again after shifting the instrument. Means we are basically shifting our instrument from this point to this point. So shifting of the instrument is known as a change point. Again, we would be taking the back side and the foresight. So this would be now the back side, and this would be now the foresight. There would be no any intermediate side since we have only two points. Now the point B have two readings, the foresight for setup A and the backside for setup, let's say the second setup. So how would be getting the elevation at point C? Similarly, we are known the height of instrument. Okay, so since height of instrument, subtracting from we would be subtracting the foresight from the height of instrument, then we would be getting the reduced level at point C. So in our next video, we are going to solve an example on this method to get more about it. Thank you very much.